The universe is a grand tapestry of light, galaxies strung like jewels along the invisible threads of the cosmic web. Each star, each cluster, burns with the silent fury of nuclear fire, filling space with brilliance and form. Yet even in this great architecture, where matter bends to the gravity of creation, there are scars. Vast regions where the stars are missing, cavities so deep they appear as wounds cut into the very fabric of existence. Among them, one stands apart. In the constellation of Eridanus lies a hollow more immense than imagination should allow. The Eridanus Supervoid, across billions of light years, it stretches, a realm where galaxies thin and then vanish, where the web itself unravels into silence. Here, the brilliance of creation falls away, replaced by something more haunting. Absence. Astronomers describe it in careful terms: an underdense region, a statistical anomaly, a void in the distribution of galaxies. But such language does little justice to the spectacle of nothingness on this scale. This is not an ordinary gap in the sky. It is a hole in the architecture of the cosmos itself, large enough to bend the ancient afterglow of the Big Bang, vast enough to leave an imprint on the cosmic microwave background. And so the questions deepen. Is the Eridanus Supervoid merely a chance fluctuation in a universe of infinite variety? Or is it evidence of something more profound, the shadow of new physics, or the silent boundary of another world beyond our own? What does it mean that the universe, so overflowing with light, allows space for so much emptiness? In the abyss of Eridanus, humanity confronts a paradox, that the largest structures in existence may be defined not by what they contain, but by what they lacked in the latter half of the 20th century. Astronomy underwent a quiet revolution. For centuries, maps of the heavens were little more than scattered points on parchment, constellations drawn by the imagination rather than by the structure of space itself. The universe was thought to be uniform on the grandest scales, a vast scattering of galaxies distributed like dust across an endless canvas. Yet, as telescopes grew more powerful, and as the science of redshift began to transform flat star charts into three-dimensional atlases, a hidden pattern began to emerge. By the 1970s and 1980s, astronomers were no longer content to look at galaxies one by one. They began to trace their distances through the faint stretching of light, measuring how much the expansion of the universe had pulled their wavelengths toward the red. Each measurement was a pin in a map, not just of where a galaxy sat in the sky, but where it dwelt in depth, across millions of light years. Piece by piece, the universe was revealed in relief, not as a random scattering, but as an intricate structure. What they found astonished them. Galaxies were not distributed evenly like grains of sand. They gathered into clusters, linked into filaments, and stretched across colossal walls of matter that spanned hundreds of millions of light years. And between these filaments, there were gaps, great cavities of near emptiness. These became known as cosmic voids, the dark seas that lay between the luminous countenance of the cosmic web. The discovery was as startling as mapping Earth for the first time and finding not just land, but entire oceans dividing it. At first, the voids were curiosities, smaller interruptions in the great fabric of the galaxy distribution. But in 1981, astronomers discovered something extraordinary. The Boat's Void, a yawning gulf nearly 330 million light-years wide, containing far fewer galaxies than expected. It was a revelation. The universe was not a smooth, evenly seeded field, but a landscape of vast contrasts, of fullness and emptiness, light and shadow. This was only the beginning. As surveys deepened, more voids were catalogued, each a silent region where galaxies thinned, then disappeared, Yet among this growing cartography of nothingness, one region remained especially enigmatic. It was not first recognized by its absence of galaxies, but by something stranger, a cold blemish in the afterglow of the Big Bang itself. In 1992, the Cosmic Background Explorer, or COBE, released its first full sky map of the cosmic microwave. Background radiation, the relic light from when the universe was only 380,000 years old. To the naked eye, it was a near-perfect uniform glow, confirming the predictions of the Big Bang, but hidden within that apparent smoothness were faint ripples, fluctuations in temperature only a few millionths of a degree. These subtle differences would become the seeds of galaxies, the fingerprints of cosmic structure itself, and yet, within this delicate pattern, there appeared a blemish, a region cooler than its surroundings, stretching across an area of the southern sky. It was unlike the others, more pronounced, larger in scale. Astronomers noted it cautiously, naming it the cold spot. Perhaps it was nothing more than statistical noise. The instruments were new, the data uncertain, but the image haunted the scientific community, for it suggested something unusual was written into the earliest light of the cosmos. A decade later, the Wilkinson Microwave Anisotropy Probe, or WMAP, confirmed the cold spot with greater precision. The anomaly remained, a patch of sky that seemed stubbornly cooler than expected. Its size was startling, nearly 10 degrees across the sky, equivalent to 20 times the width of the moon. And while random fluctuations were possible, the odds of such a feature arising by chance appeared slim. The suspicion grew, perhaps. This was not merely a quirk in the data, but a sign of structure. If light from the cosmic microwave background had crossed a vast underdense region, it could have lost energy, stretched further into the cold, and arrived to us diminished. The explanation seemed almost poetic, a hole in the universe large, enough to leave a shadow on the afterglow of creation itself. Thus began the search. Astronomers turned their galaxy surveys toward this patch of sky deep in the direction of the constellation Eridanus. Slowly, the evidence mounted. Indeed, galaxies seemed scarcer in this region, thinning into an abyss that stretched for billions of light-years. If confirmed, this would not simply be another cosmic void. It would be the Eridanus Supervoid, one of the largest empty regions ever discovered, and perhaps the true source of the cold spot. The scientific world was divided. Some saw in this vast hole a natural, if rare, feature of cosmic structure, born of the same gravitational dance that sculpted galaxies and filaments. Others doubted it could explain the cold spot at all, suggesting that the anomaly pointed to something deeper, perhaps new physics, or even the imprint of another universe brushing against our own. The debate carried with it a human weight. To map galaxies is to confront distances so immense that the mind falters. To describe a void billions of light-years wide is to stare into a silence larger than imagination itself. For the astronomers who traced these patterns, who sifted photons from the edge of time and measured the faintest of signals, the Eridanus Supervoid was more than data. It was a question, vast and unyielding, challenging the very notion of what the universe should look like. In many ways, the discovery was like that of ancient explorers who, charting the seas, suddenly encountered a gulf no map had predicted, an ocean in the middle of a continent. The Eridanus Supervoid stood as such an ocean, a great absence in the middle of cosmic presence, daring humanity to explain it. Yet the void resisted easy answers. The cold spot could be a statistical fluke, a chance ripple in the primordial light. The underdensity of galaxies might be exaggerated, a product of observational bias, and even if real, was the void large enough to account for the anomaly? The tension between observation and explanation only deepened, transforming the Eridanus Supervoid into one of the most enigmatic puzzles in cosmology. It was here, in this blend of measurement and mystery, that the seeds of wonder took root. The supervoid was not only a scientific challenge, but a philosophical mirror, for it asked not simply how galaxies are arranged, but why emptiness itself should be written so deeply into the design of reality. In the story of its discovery lay a profound reminder that sometimes the most astonishing revelations of science do not come from what we find, but from what we do not. The confirmation of the cold spot and its possible connection to a supervoid in Eridanus sent ripples through the scientific community. For decades, cosmology had rested on the reassuring foundation of the Standard Model, a universe born from a hot Big Bang, seeded with tiny quantum fluctuations and sculpted by the invisible hands of dark matter and dark energy. Within this framework, galaxies arranged themselves along filaments, leaving natural voids in between empty regions that were striking in size, but not beyond expectation. Yet the Eridanus Supervoid seemed different. Its scale defied intuition, its influence reached back to the primordial light itself, and its very existence appeared to stretch the limits of probability. For many, the discovery was not a triumph, but a disturbance, a whisper that perhaps the universe held secrets that the Standard Model could not easily contain. Some astronomers welcomed the void with fascination, seeing in it a natural outcome of cosmic variance, the statistical play of chance across an infinite cosmos. They argued that in a universe of unimaginable scale, improbable features were not only possible but inevitable. The cold spot, they reasoned, might be nothing more than one such improbable fluctuation. To others, however, this explanation felt unsatisfying. The size of the Eridanus Supervoid, combined with its alignment with the cold spot, seemed too precise, too pointed, to dismiss as coincidence. The void was not merely another dark sea between galaxies, it was a hole so vast it appeared to wound the very afterglow of creation, a structure that seemed to tug at the boundaries of what theory could easily allow. In conference halls and in quiet offices, debates unfolded. Was the cold spot truly a shadow cast by a void, or was the void itself a mirage, an illusion born of incomplete surveys and observational bias? Could the anomaly be explained by the known laws of physics, or was it evidence of something stranger? The questions carried more than scientific weight. They carried philosophical gravity. If the cold spot was indeed caused by a void of such magnitude, it would stand as one of the most extraordinary features in the observable universe. A reminder that the cosmos is not a uniform expanse, but a landscape of sharp contrasts, where fullness and emptiness weave the same tapestry. There was also skepticism, sharp and unrelenting. Some cosmologists argued that no void, no matter how large, could produce a cold spot of such scale and depth. The physics of the integrated Sachs-Wolf effect, the process by which light loses energy when passing through underdense regions, could not, they said, account for the anomaly entirely. If true, this meant that the Eridanus Supervoid, while impressive, might not be the culprit. The cold spot could instead be a statistical illusion, or worse, a sign of flaws in instruments or data processing. And yet, each new survey seemed to confirm that something unusual lurked in the direction, a persistent underdensity stretching farther and deeper than most voids ever catalogued. Behind the scientific language, there was also wonder and unease. For the scientists who mapped galaxies into 3 dimensions, each point of light painstakingly plotted, the discovery of such a void was like stumbling upon an ocean where they expected solid land. The image of the universe, once thought to be evenly seeded, now appeared scarred by vast silences. And the Eridanus Supervoid was not a silence easily ignored. It was an abyss that demanded attention, a hole that seemed to echo with questions larger than cosmology itself. In these early reactions to worlds collided, on one side the rigorous discipline of science sought to measure, to calculate, to fit the anomaly within the equations of the known. On the other, the human imagination struggled with the scale of emptiness itself, with the unsettling thought that the universe, so rich with stars, might also harbor wounds that stretch across billions of light years. The Eridanus Supervoid became a mirror for both reason and mystery, a place where statistical arguments met the haunting image of absence. And as the debates deepened, one truth became clear: whether the cold spot was an illusion, a statistical outlier, or the shadow of a vast cosmic whole, its presence forced humanity to confront the limits of understanding. For in the very act of questioning, in the struggle to reconcile theory with observation, the void had already achieved something remarkable. It had unsettled the certainty of a smooth, knowable universe. It reminded humanity that the cosmos is not merely a stage for familiar laws, but a wilderness still untamed, where even the emptiest spaces may conceal the deepest mysteries. As more data poured in, the arguments sharpened. Some insisted that the cold spot was little more than a quirk of probability, a random fluctuation magnified by human pattern-seeking minds. After all, in a universe of near-infinite scale, anomalies must arise, just as on Earth, where mountains, valleys, and deserts naturally appear in the shifting of countenance. The universe, too, could host extremes, regions of startling density alongside others of haunting emptiness. To these scientists, the Eridanus Supervoid was dramatic, yes, but not unnatural. It was a feature of cosmic geography, an extraordinary, but permissible ripple in the grand design. Others countered that this explanation leaned too heavily on chance. The cold spot was not a small blemish. It was vast, coherent, and stubbornly resistant to dismissal. Its size alone made it unlikely to be a mere roll of cosmic dice. The connection to the supervoid only deepened the unease. If this hole truly stretched billions of light years, then it was among the largest underdense regions ever identified. Its sheer scale pressed against the limits of what cosmological models comfortably allowed. To dismiss it as coincidence felt less like scientific caution and more like a refusal to confront the possibility of something profoundly new. The debates spilled into papers, conferences, and spirited exchanges between theorists and observers. Theorists argued about probabilities, running simulations to test whether such a void could realistically form in a universe governed by the CDM model, where dark matter sculpts filaments and dark energy drives expansion. Observers countered, with data showing catalogues of galaxies thinning toward Eridanus, evidence that the whole was not imagined but real. Each side clung to its strengths, theory pointing to improbability, observation insisting on presence, and between them the cold spot loomed, silent and unchanged, its mystery unaffected by human disagreement. Amid the technical debates, there was also a current of awe. To map a void is to stare into silence, and the silence of the Eridanus was unlike any other. Here, entire galactic superclusters should have resided, great congregations of stars blazing across millions of light years. Instead, there was only thin scattering, a desert in the cosmic web. The realization carried emotional weight. Scientists are trained to measure, to quantify, to reduce the vastness of space into manageable data points. But faced with this abyss, even the most rigorous minds could not help but feel something deeper, an echo of the human encounter with the unknown. The void became more than a statistic. It became an image, a wound carved into the sky, a reminder of how small and fragile our understanding remains. Skepticism persisted, as it always does in science. Some argued that the cold spot could not possibly be explained by a void alone. The physics of the integrated Sachs-Wolf effect suggested that light passing through an underdense region would indeed lose energy, but not nearly enough to account for the cold spot's depth and size. If this were true, then even a supervoid billions of light years across could not be the full answer. The implication was troubling. Either something else was at play, or the cold spot itself might be an illusion, a statistical ghost that had tricked astronomers into searching for meaning in shadows. And yet, with each refinement of the data from COBE to WMAP to Planck, the cold spot refused to vanish. With each deeper galaxy survey, the Eridanus Supervoid revealed more of its outline, its contours traced in the thinning of starlight. Both anomaly and abyss remained, bound together in a strange alignment that defied easy dismissal. It was as if the universe itself was insisting on the reality of this whole, refusing to let it be explained away. For those watching the debate unfold, the void carried with it a haunting duality. To some, it was a feature of chance, an extreme but natural part of cosmic structure. To others, it was a signpost pointing beyond the edges of accepted theory. But for all, it was a reminder of the limits of certainty. The universe, they realized, does not owe humanity clarity. It offers only fragments, shadows, glimpses of its design. And in those fragments, mystery thrives. In this way, the Eridanus Supervoid became something larger than a debate over data. It became a symbol of the scientific process itself, the tension between caution and imagination, skepticism and wonder. It reminded humanity that science is not a march toward certainty, but a dialogue with the unknown, a conversation in which each answer births new questions. The void was not simply an emptiness in space. It was an emptiness in knowledge, a gap in understanding that drew the human mind into its depths. And as the first wave of reactions faded into ongoing research, the questions remained unresolved. Was the cold spot a statistical illusion, a void's shadow, or a glimpse of something more? The early debates did not end the mystery. They deepened it, setting the stage for years of investigations to come. The Eridanus Supervoid lingered, a silent abyss etched into the cosmic web, challenging humanity to peer deeper into its darkness and discover what truths it might conceal. As the 21st century dawned, instruments grew sharper, surveys deeper, and the universe revealed itself with ever greater clarity. The Wilkinson Microwave Anisotropy Probe, known simply as WMAP, scanned the cosmos with unprecedented precision, tracing the faint whispers of the cosmic microwave background across the entire sky. Its measurements confirmed what had already unsettled astronomers. The cold spot was not a fleeting artifact or a statistical accident. It persisted, stubborn and pronounced, a subtle scar written in the first light of creation. Where once only tentative hints had appeared, now there was undeniable evidence of an anomaly, a patch of the sky cooler than its surroundings, seemingly resisting the uniformity that cosmology predicted. The persistence of this feature transformed speculation into inquiry, and inquiry into obsession. Ground-based galaxy surveys soon joined the quest, mapping the nearby universe in ever greater detail. The 2-micron or sky survey, or 2MASS, along with the Sloan Digital Sky Survey, revealed a tapestry of galaxies stretching across the southern sky, threads of light and gravity woven into the cosmic web. But in the direction of Eridanus, astronomers noticed a thinning, a gradual scarcity of galaxies that deepened into near emptiness. The supervoid was no longer a hypothesis. It was a tangible, measurable feature, its contours traced by the distribution of luminous matter. Yet even as the evidence accumulated, the work was delicate, requiring painstaking attention to the subtleties of cosmic observation. Noise, observational bias, and the random variations of the universe itself threatened to obscure the truth. To distinguish genuine structure from illusion demanded both patience and ingenuity, a careful choreography of data and interpretation. Scientists extended their scrutiny beyond the visible, turning to X-ray and radio surveys to search for hidden matter, for galaxies to faint or diffuse to appear in traditional catalogues. They scanned the sky for the faint glow of intergalactic gas, for the whispers of gravitational interactions, for anything that might betray the presence of structures lurking in the void. Each photon, each signal, became a clue, a delicate brushstroke. In the portrait of absence, the supervoid revealed itself as much through what it lacked as through what could be detected, a negative imprint on the architecture of the universe that demanded imaginative methods to perceive. Through years of methodical effort, the picture gradually sharpened. The void stretched across hundreds of millions of light-years, a hole vast enough to leave a subtle imprint on the afterglow of the Big Bang itself. Yet the discovery was not merely technical, it was profoundly human. Astronomers chased faint signals across decades, navigating the interplay of instruments and theory, driven by curiosity and a persistent wonder at the cosmos. Each survey, each cross-check, was a testament to perseverance, an act of digging through cosmic fog in search of the faintest truths. In this labor, the void took on a haunting presence, not only a region of emptiness, but a mirror of the human, longing to comprehend the incomprehensible, to map the unseeable, to find order in a silence that stretches across billions of light-years. And so the Eridanus Supervoid emerged from the shadows of observation, a vast emptiness confirmed by multiple instruments, acknowledged by multiple eyes. It was simultaneously a challenge and an invitation, a puzzle that teased both the limits of measurement and the boundaries of imagination. Every map, every photon traced a line through darkness, revealing a structure defined as much by absence as presence, a cosmic void that called forth both scientific rigor and poetic contemplation. Even as questions multiplied, the supervoid stood firm, silent, and immense, demanding recognition and respect, reminding all who observed it that in the vastness of space, the most profound discoveries often emerge from the spaces in between. The pursuit of clarity in the Eridanus direction demanded more than mere observation. It required innovation and patience. Astronomers refined techniques for measuring galaxy densities, comparing surveys taken at different wavelengths and with different instruments, seeking to distinguish genuine underdensities from artifacts of methodology. Each adjustment, each cross-check, brought a clearer sense of the supervoid's contours, yet also revealed the immense challenges of probing the universe at such scales. Cosmic variance, the inevitable randomness of structure across billions, of light years blurred the line between pattern and chance. Noise and bias threatened to mislead, demanding careful statistical analysis and rigorous verification. It was meticulous work, like sculpting an image from shadows and whispers, reconstructing presence from absence, and defining emptiness with precision. In parallel, astronomers turned to complementary datasets, searching for signatures of matter invisible to optical telescopes. Radio surveys scanned the sky for neutral hydrogen, the faint whispers of intergalactic gas that might fill the void. X-ray observations sought traces of hot plasma, the diffuse tendrils of matter that could reveal hidden structures. In these layers of the universe, the supervoid's emptiness became increasingly tangible, a negative imprint discernible through the subtle deficit of signals where there should have been light. Each new method reinforced the image of a vast hole in the cosmos, a place where galaxies were scarce, where filaments thinned, and where the cosmic web itself seemed to bend around an absence. The human effort behind these discoveries was immense. Researchers spent years, often decades, chasing faint patterns across enormous datasets, developing algorithms, conducting cross-correlations, and painstakingly confirming every anomalous signal. Observatories across the globe, from Chile's high deserts to Arizona's plains, contributed to the growing mosaic of understanding. This was not a discovery made in a single instant, but a gradual revelation, a careful peeling away of uncertainty, until the supervoid's presence could no longer be denied. Each measurement, each charted photon, was a small step toward illuminating a vast emptiness, a process that transformed abstract statistical anomalies into a tangible, almost palpable cosmic structure. And yet, even as confirmation solidified, the supervoid retained its enigmatic quality. It was not merely a gap in galaxy counts. It was a presence defined by absence, a shadow stretching across billions of light years, leaving subtle imprints on the oldest light in the universe. In the quiet rooms of observatories, among the hum of computers processing terabytes of data, the void became more than a scientific challenge. It became a meditation on scale and meaning, a testament to the patience required to trace the contours of something that cannot be seen directly, only inferred, only felt through the careful accumulation of evidence. By the close of this phase of early investigation, the Eridanus Supervoid had emerged from uncertainty into recognition. Its existence was no longer conjecture, no longer a mere blip in cosmic surveys. Yet it remained elusive in its implications, a silent, stretching cavity that questioned assumptions and inspired wonder. The human endeavor to map it was ongoing, a journey across both space and understanding, reflecting the persistence, ingenuity, and reverence of those who seek to comprehend the universe. The supervoid was no longer a subtle anomaly. It was a testament to the vastness of cosmic emptiness, a reminder that even in a universe teeming with stars, silence and absence can be as profound as light. With the launch of the Planck satellite in 2009, the universe revealed itself with unprecedented precision. Its oldest light traced across the sky in exquisite detail. Every fluctuation, every subtle ripple in the cosmic microwave background was measured, catalogued, and scrutinized, and the cold spot, that enigmatic, chilling blemish in the primordial glow, persisted with unwavering clarity. It was no longer a statistical curiosity, nor a quirk of instrumentation. The cold spot was real, a tangible anomaly embedded in the universe's earliest light, hinting at something vast and unseen beyond the reach of ordinary observation. Scientists pored over the data with a mixture of excitement and trepidation, recognizing that this feature might be the signature of something both profound and inexplicable, as Planck's refined observations coalesced. Astronomers turned their attention more sharply toward the region of the sky corresponding to galaxy surveys conducted in optical, infrared, and radio wavelengths revealed a dramatic thinning of matter. The under-dense region stretched across hundreds of millions of light-years, a cavernous emptiness so immense it seemed to defy comprehension. The Eridanus Supervoid, once a shadowy concept inferred from faint signals and statistical hints, emerged in the data as a structure of undeniable scale. Its contours were traced not in the brilliance of stars, but in their absence. A cosmic void whose dimensions rivaled or exceeded those of any previously known emptiness in the observable universe. The statistical analyses confirmed the astonishment of the observers. Within the standard CDM cosmology, such a vast void should be extraordinarily rare, a feature whose probability of appearing by chance bordered on the improbable. Yet there it was, a gulf of emptiness aligned with the cold spot, suggesting a possible causal link between structure and ancient light. Photons from the cosmic microwave background passing through this region would lose energy, subtly cooling as they traversed the underdense expanse, leaving an imprint on the afterglow of the Big Bang itself. The alignment, while not conclusive, ignited a surge of scientific thrill. The possibility that the supervoid could account for the cold spot transformed speculation into plausible explanation, a bridge between observation and theory that brought an almost poetic satisfaction to the endeavor. In the minds of those who studied it, the Eridanus Supervoid became more than a collection of data points. It was a cosmic wound, a hole carved into the universe so vast that its presence was felt across billions of years of light. The void challenged intuition, prompting reflection on scale and absence, on the subtle interplay between presence and emptiness. To gaze at the supervoid through Planck's measurements was to witness a negative imprint on the universe itself, a silence so profound that it reshaped the contours of the observable cosmos. Scientists described it carefully, yet in quieter moments, beyond the equations and simulations, they could not escape the emotional weight of what they were seeing, a region of nothingness, vast enough to touch the echo of creation, a whole whose imprint stretched from the dawn of time to the eyes of those who dared to map it. The breakthrough was not merely technical, it was existential. For the first time, humanity could chart the contours of a void so immense that it reshaped the narrative of cosmic structure. The Eridanus Supervoid was no longer a shadow in data, nor a speculative feature lurking at the margins of theory. It was a real, measured, and awe-inspiring element of the cosmos, a reminder that the universe is defined as much by its absences as by its luminous matter. In that silence, stretching across hundreds of millions of light-years, lay both scientific challenge and poetic wonder, a testament to the scale, mystery, and beauty of a universe that continues to surprise, humble, and inspire. Even as researchers confirmed the void's presence, the questions deepened. Was the alignment with the cold spot coincidental, or did it hint at unknown physics? Could other mechanisms, unseen yet fundamental, amplify the effects of such emptiness? On ancient light, each discovery brought new layers of inquiry, expanding both understanding and mystery. And throughout it all, the Eridanus Supervoid persisted, silent yet eloquent, a cavern carved in the universe's fabric, its vastness inviting reflection, contemplation, and awe. In this breakthrough, the emptiness itself became a revelation. A whole not only in space, but in comprehension, reminding humanity that some of the most profound truths are discovered not in what is present, but in what is astonishingly absent. The implications of the Eridanus Supervoid were immediate and profound. Here was a structure so vast that it forced astronomers to reconsider the scale at which the universe organizes itself. The void was not a small indentation in the cosmic web. It was a yawning gulf, stretching over hundreds of millions of light-years. A silence so immense that it left a measurable imprint on the cosmic microwave background. Researchers found themselves standing on the threshold of a paradox. The universe, in its infinite expanses, was filled with light and matter, yet here was a region defined almost entirely by absence. The juxtaposition was haunting, a reminder that even the brightest cosmos carries within it shadows of unimaginable scale. Simulations ran endlessly in supercomputers, modeling the growth of structure over billions of years. Dark matter and dark energy, the invisible architects of the cosmos, were fed into the calculations, yet replicating a void of such magnitude proved difficult. Within the standard cosmological framework, the probability of forming a structure of this size was vanishingly small. Some theorists suggested that perhaps the supervoid was a rare, extreme outcome, a statistical outlier in a universe vast enough to accommodate such anomalies. Others allowed their imaginations to wander into more speculative territory, wondering whether the void might hint at phenomena beyond current understanding, hints of physics still waiting to be discovered, or even traces of interactions beyond our observable universe. Amid these theoretical deliberations, the observational data continued to impress. Galaxy counts in the Eridanus direction remained sparse. The supervoid's contours confirmed by multiple independent surveys across optical, infrared, and radio wavelengths. The void was increasingly seen not as an abstract feature, but as a physical reality, a structure whose scale and alignment could no longer be ignored. And in its very emptiness, it offered a new lens through which to contemplate the universe, that absence can carry meaning, that a hole in space can become a signature, a record of cosmic evolution written in the language of light and shadow. Scientists spoke of the void with a mix of precision and reverence. It was quantified in megaparsecs and redshift, yet these numbers failed to convey its immensity. To think of it in human terms was almost impossible. It was a region larger than any supercluster, larger than entire chains of galaxies, a cavity in the cosmos whose vastness exceeded ordinary comprehension. Yet through the combined efforts of Planck, WMAP, 2MASS, and SDSS, humanity had for the first time measured and begun to understand this emptiness. The supervoid was no longer merely theoretical, no longer a statistical curiosity. It was an observable, measurable feature, a cosmic wound whose echo reached across billions of light-years to the faint glow of the early universe. And still, the cold spot loomed as a tantalizing companion to this discovery. The alignment suggested a causal connection, though certainty remained elusive. Could the supervoid fully account for the temperature decrement observed in the cosmic microwave? Background, perhaps, or perhaps additional, subtler physics were at play, yet to be discovered or understood. The thrill of possibility coursed through the scientific community. Here was evidence of a phenomenon that bridged the earliest light, of the universe with the large-scale structure of galaxies, a whole so vast it left a permanent impression on the afterglow of creation itself. Even as researchers celebrated the breakthrough, the supervoid retained its enigmatic presence. Its silence was profound, yet eloquent. It was a reminder that the universe is as much defined by what is missing as by what is present, that the most extraordinary revelations sometimes emerge not in clusters of light, but in the enormous, stretching absence between them. In the Eridanus Supervoid, humanity found both a puzzle and a mirror, a reflection of the vastness of space, the limits of comprehension, and the persistent drive to map, measure, and understand the cosmos. Here, in this immense cavity, the universe whispered its secrets through absence, leaving observers both humbled and inspired by the magnitude of emptiness and the subtle traces it imprints upon time, light, and imagination. The Eridanus, immense and undeniable, had been measured, mapped, and confirmed. Its contours stretched across hundreds of millions of light years, a cavernous absence carved into the fabric of the cosmic web. Yet even as its existence was established, a subtle unease settled among cosmologists. The void, enormous though it was, might still be insufficient to fully account for the cold spot in the cosmic microwave background. The temperature decrement observed by Planck and WMAP was deeper, more pronounced than the integrated Sachs-Wolf effect of a void of this size could reasonably explain. And so, the discovery that had seemed to solve one cosmic puzzle instead revealed another. A tension between what was observed and what theory predicted, between the vast emptiness mapped in galaxy counts and the stubborn chill imprinted on the earliest light of the universe. Alternative ideas began to emerge, tentative and speculative, probing the edges of understanding. Could there be additional features hidden within the void, structures invisible to traditional surveys, fluctuations of dark matter or dark energy yet unaccounted for? Some theorists suggested that the cold spot might hint at phenomena entirely unknown, relics of processes from before the inflationary epoch, or interactions with regions of the cosmos beyond our observable horizon. In these possibilities, the supervoid became more than a simple underdense region. It became a gateway to deeper questions, a whisper of the universe's hidden architecture, hinting that there may be truths that our instruments can barely perceive, and our models scarcely encompass. The situation evoked a historical resonance, a quiet, cautionary echo from the history of physics. Just as the luminiferous ether was once postulated to explain the propagation of light, an invisible medium that ultimately did not exist, perhaps the void, too, was masking a subtler unknown, a structure or principle yet beyond comprehension. The analogy was not lost on the scientific community. The universe had a way of humbling its observers, revealing that each solution often unfolds into a deeper mystery, that absence can be as revealing as presence, and that the most profound truths may reside precisely in what seems empty. This tension between observational certainty and theoretical puzzlement grew with every new survey and simulation. On one hand, the Eridanus Supervoid was undeniable, a measured, mapped, and replicable structure. On the other hand, its presence seemed insufficient to account for the full extent of the cold spot, forcing cosmologists to confront the limits of current models. Was the standard CDM cosmology incomplete in subtle ways? Could the void be pointing to cracks in our understanding of dark energy, dark matter, or the early universe itself? Such questions stirred both excitement and philosophical unease. The void was no longer merely a feature of space. It was a mirror reflecting the limitations of human knowledge, a silent interlocutor challenging assumptions long held as fundamental. in the quiet contemplation of this immense emptiness, the super took on an almost lyrical quality. It was a cavern carved across billions of light years, yet it spoke not with noise or signal, but with absence, a whisper from a universe that had not fully revealed itself, each photon from the cosmic microwave background passing through. Its expanse carried the subtle imprint of its voided passage, a message encoded in silence. To gaze at the supervoid, to trace its contours in data and imagination alike, was to confront the humbling reality that the universe is far more intricate and enigmatic than human intuition allows. The Eridanus Supervoid, this colossal whole, was no mere curiosity. It was a profound reminder that in the cosmos, emptiness is itself a form of presence, and that in the spaces we do not fully understand, the universe speaks its quietest, most compelling truths. As investigations pressed forward, the void's very enormity became both awe-inspiring and confounding. The scale of Eridanus was difficult to reconcile with conventional structure formation. Galaxies, clusters, and filaments were expected to populate the universe in patterns predicted by dark matter and dark energy. Yet here was a region so underpopulated that it challenged assumptions about how matter coalesces across cosmic time. Cosmologists began to run increasingly sophisticated simulations, feeding in variables for dark energy density, cosmic expansion, and primordial fluctuations. Yet even these models struggled to produce a void of comparable scale and depth. It was as though nature had deliberately constructed a space that defied expectation, a lacuna that both existed and resisted easy comprehension. The tension between observation and theory sparked a surge of speculation. Could the supervoid be a remnant of some primordial event, a footprint left by processes in the earliest moments after the Big Bang? Inflation, the rapid expansion of space-time fractions of a second after creation, might leave subtle imprints in density distributions, but would it produce a cavity of this magnitude, so precisely aligned with the cold spot? Others proposed that the void might be indicative of phenomena beyond the observable universe, regions where our cosmological horizon ends, and where unseen forces or structures might influence the light and matter we can detect. In these conjectures, the void became more than a mere underdensity. It became a signpost pointing toward hidden dimensions of reality, a subtle indicator that the universe's architecture might be richer, stranger, and more layered than any single model could capture. This growing complexity weighed on the scientific imagination. Observers and theorists alike were reminded that certainty in cosmology is provisional, subject to the slow accumulation of evidence and the constant probing of limits. The void was measurable, undeniable, yet it simultaneously evaded definitive explanation. Each photon from the cosmic microwave background that passed through its expanse carried a story partially understood, a subtle distortion hinting at vast structures yet fully decoded. In this sense, the Eridanus Supervoid was not just a feature of space. It was a bridge between the known and the unknown, a reminder that even in the rigor of measurement, the universe reserves moments of mystery. Philosophical unease grew in parallel with scientific curiosity. The supervoid posed questions that could not be answered by data alone. Did its existence reveal cracks in the standard cosmological model? Hints that dark energy or dark matter behaved differently than predicted across extreme scales? Could there be mechanisms, entirely unseen, influencing the distribution of galaxies and the flow of light across billions of years? And beyond the equations and simulations, there was the human response, the quiet awe that comes when one confronts the immensity of absence, the emotional resonance of a space so vast it challenges comprehension. The Eridanus Supervoid was a silence loud enough to provoke reflection, an emptiness that demanded not only measurement but philosophical reckoning. In the end, the void remained both a scientific challenge and a poetic presence. It was a hole in the cosmic web, yes, but it was also a whisper from a universe that is far larger, far more mysterious than even our most sophisticated models allow. The cold spot, the supervoid, and the tension between them became intertwined, a delicate dance of observation and speculation. For every answer proposed, new questions arose, each one hinting at deeper layers of structure, physics, and meaning. And in the space between certainty and speculation, the void endured, silent yet eloquent, a reminder that in the cosmos, absence is never empty. It is a canvas upon which the universe writes its most profound and elusive truths, at the frontier of cosmology, where observation meets speculation. The Eridanus Supervoid occupies a realm both tantalizing and confounding. Here, researchers began to explore connections between the void and fluctuations in dark energy, that enigmatic force driving the accelerated expansion of the universe. Could subtle variations in dark energy density over immense scales have created or amplified such a vast underdense region? The idea was both seductive and unsettling. A hole in space, not merely shaped by matter and gravity, but sculpted in part by the invisible hand of dark energy, whispering across billions of light years. These were not idle speculations, but serious attempts to reconcile the supervoid's enormity with the persistent chill of the cold spot, to find in the universe's most shadowed regions a tangible manifestation of its most mysterious forces. Other lines of inquiry ventured even further, tracing the origins of the supervoid back to the earliest moments of cosmic history. Theories of inflation, the rapid expansion of the universe, fractions of a second after the Big Bang, suggest that tiny quantum fluctuations in energy density could be stretched across unimaginable distances. Could one such fluctuation have seeded the Eridanus Supervoid, leaving a cavity so immense that it echoes across the cosmos even today? In this scenario, the void becomes a fossil, a tangible imprint of processes from the birth of time itself. It is a bridge between quantum uncertainty and cosmic scale, a silent monument to the universe's most extreme and ephemeral moments. Now written into the sky in the absence of galaxies, the void also invites consideration as a cosmic lens. Although empty of luminous matter, a supervoid still warps space-time subtly, bending light as it traverses the abyss. Photons from distant galaxies and the cosmic microwave background may experience slight delays, shifts, or distortions there, paths altered by the gravitational signature of emptiness itself. In this sense, the Eridanus Supervoid becomes both a void and a mirror, a lens through which the structure of the cosmos and the nature of space and time may be probed in ways that challenge intuition. Even absence can exert influence, leaving traces not in matter, but in the flow of light and energy across the vast cosmic web. High-precision simulations have sought to test whether such a structure could naturally evolve within the known laws of physics. Supercomputers model the growth of galaxies, filaments, and voids, factoring in dark matter, dark energy, and the initial density fluctuations inherited from inflation. These simulations suggest that voids of remarkable size can appear through the natural evolution of the cosmic web, yet reproducing one aligned with the cold spot proves difficult. The Eridanus Supervoid sits at the extreme edge of these models, a structure so improbable that it strains the boundaries of expected variance. Even with sophisticated calculations and expansive datasets, the void challenges assumptions, forcing cosmologists to confront the limits of current understanding. In this domain, science begins to feel less like measurement and more like contemplation. The universe, at its furthest reaches, resists certainty. Observers can map galaxies, calculate redshifts, and trace the CMB with exquisite precision, yet the Eridanus Supervoid persists as both evidence and enigma. At the edge of measurement, the cosmos seems to blur, revealing patterns and absences that hint at deeper truths, yet evade definitive explanation. The void stands as a testament to both human ingenuity and cosmic humility, a reminder that even as instruments and models grow ever more precise, some features of reality remain profoundly elusive, whispering of forces, origins, and structures that may forever stretch the imagination. Here, at the extreme edge of science, the Eridanus Supervoid embodies the intersection of known and unknown, of fact and speculation, of measured emptiness and poetic resonance. It is a cavern in the cosmic web, a silence that resonates across billions of light years, a whole whose very existence challenges the boundaries of understanding and invites the mind to dwell, wonder, and contemplate the subtle complexities of the universe at its most profound scale. Even as cosmologists explored the possible roles of dark energy and inflationary fluctuations, the Eridanus Supervoid continued to challenge assumptions about the predictability of the cosmos. Its scale was not merely large, it was extreme, a structure that occupied the outermost boundaries of statistical expectation. In trying to model its formation, researchers confronted the unsettling possibility that current cosmological frameworks might be incomplete or require refinement at the largest scales. Could there be subtle forces or hidden dynamics influencing the distribution of matter and the behavior of light across the universe? The void suggested that the universe might harbor processes yet unimagined, phenomena whose faint signatures reach us only as subtle absences, as silences etched into the cosmic web. Some theorists began to entertain the notion that the supervoid might act as a lens of a different kind, not bending light through mass, but warping it through emptiness. Its low-density region alters gravitational potentials, producing tiny but measurable effects on passing photons, subtly cooling or delaying their journey. In this sense, the void was active in its passivity, influencing the universe by its very lack of content. It became a paradoxical agent of change, a whole that shapes what is seen not by the matter it contains, but by the void it represents. Each photon traveling through Eridanus carries with it a faint echo of this emptiness, a whisper of something vast and intangible that continues to ripple across billions of light years. The simulations required to probe these possibilities grew ever more complex. Researchers pushed computational models to their limits, incorporating dark energy dynamics, initial density perturbations from inflation, and the intricate web of matter that forms galaxies and clusters. Even within these high-resolution models, reproducing a void of the Eridanus Supervoid's magnitude and alignment with the cold spot proved extraordinarily rare. The extremity of the structure suggested either a remarkable statistical anomaly or perhaps a hint of physics beyond the standard model, new processes, new interactions, or new features of the universe that remain concealed beyond our current instruments. It was a humbling reminder that even the most elegant theories are provisional, capable of being challenged by phenomena that stretch imagination as much as data. Beyond the calculations, the void exerted a profound psychological and philosophical pull. Observers were struck by its vast silence, the contrast between the brilliance of stars and galaxies elsewhere and the emptiness that defined this region. The supervoid became a symbol of cosmic humility, a reminder that the universe is not obliged to reveal its secrets fully. In confronting the Eridanus Supervoid, scientists were forced to navigate a tension between empirical rigor and speculative imagination, between what could be measured and what could only be inferred. It was a domain where absence became as informative as presence, where the void itself communicated, if only in whispers. The subtle complexity of a universe, still largely unknown, at the edge of measurement. Reality itself seemed to blur. The Eridanus Supervoid was not merely a challenge to existing models. It was a canvas upon which the universe displayed its most elusive and elegant subtleties. It was a whole that resonated across space and time, a structure that reminded humanity that even in the vastness of creation, mystery persists. As the simulations ran, the surveys deepened, and theoretical explorations ventured further. The void remained both a scientific enigma and a poetic presence, a bridge between the measurable and the unimaginable, a silent monument to the profound interplay between light, matter, and absence in the architecture of the cosmos. Within the framework of mainstream cosmology, the Eridanus Supervoid is often interpreted through the lens of the integrated Sachs-Wolf effect, a subtle phenomenon in which photons traveling through underdense regions gradually lose energy. As cosmic microwave background photons traverse the vast emptiness of Eridanus, their journey is slightly slowed, their temperature subtly diminished, leaving an imprint in the oldest light of the universe. This explanation, rooted in well-established physics, offers a bridge between observation and theory. The cold spot might be less a mystery than a record of the universe's own large-scale structure, a faint echo of photons interacting with the contours of cosmic emptiness over billions of years. Yet even as this effect provides a plausible mechanism, it carries with it an understated tension. The void is enormous, and the degree of cooling observed is more extreme than simulations often predict. Cosmic variance offers another avenue of understanding, a statistical acknowledgement that even within the bounds of standard lambda CDM cosmology, extraordinary features can and do appear. The Eridanus Supervoid, by this reasoning, is improbable but not impossible. In a universe as vast as ours, rare anomalies are expected to emerge, outliers that challenge intuition but ultimately fit within the probabilistic framework of structure formation. This perspective allows scientists to reconcile the super with existing models, framing it as a natural, if exceptional, outcome of the processes that shaped the cosmic web. It underscores the delicate balance between expectation and reality, reminding us that rarity does not preclude existence, and that even the most unlikely formations can arise naturally from the interplay of gravity, dark energy, and the initial density fluctuations left by inflation. The architecture of the cosmic web itself lends further context. Surrounding the supervoid, filaments of galaxies and clusters trace intricate patterns, bending and branching in ways that frame the emptiness like the negative space in a masterpiece painting. These structures may have influenced the evolution of the void, shaping its boundaries and accentuating its depth. By comparing Eridanus to other known voids, cosmologists can estimate the likelihood of such a formation, situating it within a continuum of emptiness that punctuates the large-scale structure of the universe. Each comparison, each survey, each Simulation contributes to a growing understanding, yet none fully dissolves the sense of wonder that accompanies a whole. So vast it imprints itself upon the relic radiation of the Big Bang. Even within these mainstream explanations, a sense of incompleteness persists. The physics of the integrated Sachs-Wolf effect is understood, and the statistics of cosmic variance are quantifiable. Yet the alignment of the cold spot with the supervoid and the extreme scale of Eridanus continue to invite reflection. It is as though the universe offers a rational answer, and at the same time a poetic one, hinting that explanation alone cannot capture the full resonance of absence on this scale. The void is both accounted for and still mysterious, a tension between empirical certainty and the human impulse to comprehend. In acknowledging these mainstream interpretations, observers confront a profound truth. Even our most elegant theories leave room for awe, for questions that extend beyond equations, and for the silent majesty of a whole whose magnitude defies imagination, yet whose imprint is undeniable. Through the lens of these standard cosmological principles, the Eridanus Supervoid emerges as simultaneously understandable and extraordinary. It exemplifies the power of known physics to illuminate the universe's architecture while retaining a subtle, almost poetic, defiance of complete comprehension. Here, mainstream theory offers clarity without fully dispelling mystery. A reminder that in the vast expanse of space, even holes have stories, and even answers carry echoes of the unknown. The void is, in this sense, both a solution and a question, a structure that allows us to trace the contours of the cosmos while pointing toward horizons we have yet to explore, even as the integrated Sachs-Wolf effect provides a framework for understanding the cold spot. The sheer scale of the Eridanus Supervoid continues to provoke contemplation. While photons lose energy crossing under dense regions, the depth and alignment of the cold spot suggest that Eridanus is at the extreme end of what standard models can produce. In this context, the void becomes a natural laboratory for testing the limits of lambda CDM cosmology, a structure that is both predicted and exceptional, a rare manifestation of the statistical universe. The interplay between ordinary physics and extraordinary scale invites a sense of humility. Even the most well-established models must accommodate phenomena that stretch the imagination, reminding scientists that anomalies are as essential to understanding as confirmations. The surrounding cosmic web frames the void in a way that further enriches the narrative. Galaxy filaments and clusters, like threads in an immense tapestry, outline Eridanus, highlighting the contrast between presence and absence. These structures are not incidental. They are integral to the evolution of the void, guiding the flow of matter and influencing the shape and depth of emptiness over billions of years. By mapping these filaments and comparing Eridanus to other voids, cosmologists can begin to gauge its rarity, situating it within a continuum of large-scale structures that punctuate the universe. Yet the comparison is never complete, for Eridanus remains an extreme outlier, a void that simultaneously conforms to theory and challenges expectation, a reminder that even in well-understood frameworks, nature retains the power to astonish. Statistical analyses of large-scale surveys provide reassurance, yet they also underscore incompleteness. The probability of a void this large arising naturally is low but non-zero. It is an improbable feature that emerges from the chaotic, stochastic processes governing the universe's growth. In this probabilistic sense, Eridanus is both natural and remarkable, a rare fluctuation that has been rendered visible by decades of meticulous observation. The tension between expected rarity and observed reality imbues the supervoid with philosophical weight. It is not simply an object to measure, but a phenomenon that evokes reflection on the balance between determinism and chance, order and randomness, presence and absence in the cosmos, even as mainstream explanations provide a scaffold for understanding. The void's narrative retains a poetic dimension. The integrated Sachs-Wolf effect quantifies photon cooling. Cosmic variance frames its probability, and the lambda CDM model situates it within a broader structure. Yet none fully captures the experiential magnitude of its emptiness. Observers are left with both clarity and wonder, an appreciation for the predictive power of physics alongside a recognition of the universe's persistent mystery. The supervoid is a whole that is both explained and elusive, a structure that illustrates the interplay between rigorous science and the ineffable scale of cosmic architecture. In this delicate balance, mainstream theory affirms its explanatory power while leaving space for contemplation, reminding us that in the vast emptiness of space, even absence carries profound significance, echoing across light years and cosmic time with silent eloquence. At the outer edges of cosmological thought, where mainstream explanations begin to falter, the Eridanus Supervoid becomes a canvas for speculation, a stage upon which the most daring ideas take shape. Some theorists propose that the cold spot may be a whisper of the multiverse itself, a subtle scar in our universe caused by a collision with another bubble of space-time. In this view, the void is not merely a region of emptiness within our cosmos, but a footprint of an event that transcends the boundaries of observation. Photons from the cosmic microwave background might carry the faint imprint of such an encounter, a chilling reminder that the universe we inhabit may be one among countless others, each with its own geometry, physics, and fate. The notion is as unsettling as it is beautiful, a whole that hints at something beyond, a cosmic tremor echoing across unimaginable distances and epochs. Other speculative theories arise from the earliest moments of cosmic evolution, suggesting that the supervoid may be a manifestation of cosmic textures, relics left behind during symmetry-breaking events shortly after the Big Bang. In these models, the fabric of space-time itself bears scars, areas where the uniformity of the universe was disrupted, leaving behind faintly imprinted structures that persist across billions of years. Such textures could create temperature anomalies in the CMB, potentially accounting for the cold spot's extraordinary depth. Here, the void becomes more than an absence. It is a silent record of primordial physics, a relic of processes that shaped the universe at its infancy, offering a rare glimpse into conditions so extreme they defy direct observation. Some hypotheses push further still, contemplating exotic physics in which the void represents a region of altered dark energy density. In these scenarios, Eridanus is not simply empty space, but a domain where the acceleration of cosmic expansion behaves differently, subtly influencing the motion of matter and the flow of light across its expanse. Others imagine hidden structures within the void itself, filaments of dark matter that remain invisible to telescopes, shaping gravitational potentials and leaving faint imprints on passing photons. In these visions, emptiness is never absolute. It is a layered, dynamic, and partially concealed architecture, revealing that absence can be as complex as presence, and that what appears vacant may nonetheless exert profound influence across cosmic scales. Philosophically, the void takes on an almost reflective quality, a mirror for human perception and limitation. It challenges assumptions about what can be known, compelling us to confront the possibility that the universe is more intricate, more subtle, and more enigmatic than even our most sophisticated instruments can reveal. The Eridanus becomes a locus for contemplation, an embodiment of the tension between what is measurable and what is imaginable, between certainty and wonder. It is a whole whose emptiness carries presence, whose silence resonates with the unanswered questions that drive scientific curiosity, and whose scale dwarfs the human mind even as it invites reflection upon the nature of existence itself. At this speculative edge, the allure of the void is haunting. It is a place where imagination and science intertwine, where the rigor of observation meets the boldness of conjecture, and where the universe hints at dimensions and forces that may forever lie beyond direct comprehension. The Eridanus Supervoid is not simply a structure in space. It is a symbol of the unknown, a profound testament to the mysteries that persist even in an era of unprecedented cosmic mapping. In its vast, silent expanse, it challenges humanity to extend the boundaries of thought, to accept the coexistence of explanation and wonder, and to recognize that some holes in the cosmos may be as much about the limits of understanding as they are about the emptiness they contain. Even as the multiverse hypothesis and cosmic textures captivate imaginations, the Eridanus Supervoid continues to invite subtler, more nuanced forms of speculation. Could it be that what appears as emptiness conceals layers of structure invisible to ordinary observation? Dark matter, the invisible scaffolding upon which galaxies form, may weave filaments through the void, ghostly threads undetectable by optical telescopes, yet influencing the motion of light and matter. In this vision, the void is not absolute. It is a shadowed labyrinth, an intricate choreography of gravitational influence and absence, where the very nothingness that defines it becomes a medium through which the universe communicates. Each photon passing through carries a faint memory of this hidden architecture, a whisper encoded in the cosmic microwave background, subtly altering its temperature and polarization in ways that challenge measurement and interpretation. The void also embodies a profound philosophical resonance. It confronts observers with the limits of perception and comprehension, a stark reminder that even with the most precise instruments and the most sophisticated models, the universe can present phenomena that defy full understanding. The super is simultaneously known and unknown, measured and mysterious. Its presence forces a reflection not only on cosmic processes, but on human cognition itself. How to reconcile empirical knowledge with the scale and subtlety of phenomena that exceed immediate intuition. In this sense, the whole becomes a mirror, reflecting the boundaries of observation and the humility required to approach the cosmos. It reminds us that some truths may only be suggested, never fully grasped, and that the act of inquiry itself, of mapping, modeling, and theorizing, is a dialogue with the unknown. Speculative physics offers further possibilities, exploring regions where the density of dark energy may vary subtly from the surrounding universe. In such models, the supervoid could represent a localized fluctuation, a region where the expansion of space itself behaves differently, creating gravitational and photonic effects that produce the cold spot signature, while direct evidence for such variations remains elusive. The concept opens a window onto the idea that what we perceive as emptiness may be a dynamic, energetic landscape in its own right. The void, in this view, is not merely a lack of galaxies. It is an active participant in the cosmos, shaping the journey of light, the evolution of structure, and even the frameworks through which we understand space and time. Amid these theories, the Eridanus Supervoid assumes a haunting allure. It is a place where science brushes against the edges of imagination, where measurement and mystery coexist, and where the scale of emptiness itself evokes both awe and reflection. It becomes a symbol of the universe's capacity to surprise, to suggest possibilities that extend beyond current understanding, and to challenge the assumptions that underpin even the most robust cosmological models. The supervoid is not simply a phenomenon to be catalogued. It is a locus of contemplation, a reminder that in the cosmos, absence can carry meaning, and that a hole in space can illuminate the profound complexity, subtlety, and wonder of the universe in ways that presence alone never could. The mystery of the Eridanus Supervoid has not been left to linger in silence. Across the world, vast collaborations of astronomers and cosmologists continue to refine their gaze, building instruments capable of peeling back the faintest layers of the universe's structure. Surveys like the Dark Energy Survey, the Vera C. Rubin Observatory's Legacy Survey of Space and Time, and the upcoming Euclid mission trace the cosmic web with unprecedented fidelity, cataloging billions of galaxies to map the voids and filaments with a precision never before possible. These surveys act as cartographers of the invisible, charting the universe's architecture not through conjecture but through the painstaking accumulation of light from across the heavens. In their data, the Eridanus Supervoid is dissected, measured and tested, each new observation bringing sharper clarity to its shape and scale, and yet deepening the quiet awe that accompanies its discovery. To probe the true depth of Eridanus, scientists cross-correlate galaxies with the explosions of distant supernova and the clustering of massive galaxy groups. Each supernova acts as a cosmic lighthouse, illuminating how matter is distributed along its path. By combining these markers, researchers can test whether the void is as empty as it seems or whether subtle structures remain concealed in its vastness. In parallel, gravitational lensing, the bending of light by mass, is applied to the region, not to magnify galaxies as in richer clusters, but to test the absence of distortion. Where little bending occurs, absence is confirmed, affirming that here, truly, the universe thins into a cosmic hollow. It is a striking inversion of the technique, using the silence of lensing, the near invisibility of effect, as proof of an immense absence. Meanwhile, the cold spot itself remains under scrutiny. Next-generation missions, building on the legacy of COBE, WMAP, and Planck, aim to refine measurements of the cosmic microwave background to levels of precision that border on the impossible. Tiny fluctuations in temperature, variations measured in millionths of a degree, become the tools through which scientists attempt to confirm whether the cold spot is truly the fingerprint of the Eridanus Supervoid, or whether another process lies beneath. These missions, with their delicate instruments cooled to near absolute zero and their orbits far from Earth's warmth, extend human perception into realms where silence itself becomes data. Yet the effort to understand this void is not confined to astrophysics alone. It has become a point of convergence where cosmology brushes against particle physics, and where both, in turn, provoke reflection within philosophy of science. The Eridanus Supervoid compels a re-examination of models that once seemed unshakable, drawing together communities that span not only continents but disciplines. Here data becomes dialogue between theorists and observers, between those who construct simulations of structure formation and those who chart the faint galaxies on the edge of detection, between those who question the limits of knowledge and those who seek to extend them. It is a pursuit that is at once technical and profoundly human, driven by the same wonder that inspired early astronomers to map the stars with naked eyes. The human dimension of this quest is perhaps its most telling feature. The scientists who dedicate years, even decades, to chasing signals across the sky are bound by more than equations and instruments. They are bound by a shared recognition of beauty and mystery. The Eridanus Supervoid is not just a problem to solve, but a reminder of what it means to explore, to reach into the unknown with patience, humility, and persistence across laboratories, observatories, and simulation clusters. There is an unspoken acknowledgement that the void's significance lies not only in its physical reality, but in the questions it evokes, the boundaries it challenges, and the shared sense of awe it inspires. It is a whole that has united a community across generations, a silent beacon guiding inquiry, and a reminder that science is, at its heart, a human story written against the canvas of the cosmos. The pursuit of the supervoid is also a pursuit of limits, the limits of instrumentation, of models, of imagination itself. Each new survey adds resolution to the cosmic map, but also expands the horizon of questions. The Dark Energy Survey, for instance, has already revealed intricate patterns in the cosmic web, where voids intertwine with filaments like negative spaces in a grand sculpture. Euclid, now taking its place in orbit, promises to deepen that portrait with precision imaging across vast swaths of the sky, revealing how matter bends and stretches across billions of light years. And yet, even as the maps grow sharper, the cold spot remains, its quiet anomaly immune to easy dismissal. Like a riddle hidden within a masterpiece, it seems designed to remind science that measurement does not guarantee explanation. Computer simulations have become laboratories of a different kind, universes grown inside silicon, where gravity, dark matter, and dark energy are given a digital stage to evolve across cosmic epochs. In these simulated skies, supervoids emerge naturally, their vast expanses hollowed out by the relentless pull of surrounding matter. But rarely do they reach the scale of Eridanus, and almost never do they produce distortions as striking as the cold spot. The comparison between observation and simulation forces cosmologists into uneasy territory, where the familiar language of the standard model falters. Here, science is confronted with a void that is not merely physical but conceptual, a gap between what the equations predict and what the universe presents. As these tensions mount, attention turns to subtler techniques. Weak gravitational lensing, for instance, becomes a kind of stethoscope pressed against the chest of the cosmos, listening for the faint pulse of invisible matter. The bending of light around galaxies and clusters tells the story of mass unseen, a shadow map of dark matter woven through the void. If Eridanus is truly emptier than any known structure, its lensing signature should confirm that absence. But if hidden filaments linger, strands of dark matter, invisible to galaxies, they may whisper through the faint distortions of background light. In this way, the void becomes less a blank space and more a question mark, its contours sketched by what light fails to do, behind the machinery of observation and the rigor of analysis. There remains the enduring human impulse that sustains these efforts, a community of researchers scattered across continents, yet united by the same sky works in quiet persistence, often knowing that the answers may remain elusive. Conferences filled with debate, late nights spent cross-checking data, and simulations run on supercomputers for weeks at a time. All of these are fragments of a collective endeavor. What drives them is not certainty of resolution, but the recognition that within the void lies a profound test of understanding. The Eridanus Supervoid is both object and mirror, an immense structure in the cosmos, and a reflection of humanity's refusal to settle for the comfort of the known. Across the ages, humanity has stared into darkness and filled it with meaning. Ancient cultures imagined the abyss as the birthplace of creation, a formless chaos from which order emerged. In Mesopotamian myth, the void was a primordial sea. In Greek thought, it was chaos itself, the yawning gap out of which the cosmos was born. Even in modern science, the void persists, not as a divine womb, but as a real structure woven into the fabric of space. The Eridanus Supervoid becomes the newest incarnation of an old archetype, the whole that both terrifies and defines existence. It is a silence that speaks, a space that shapes the music of galaxies by the absence of their song. Yet to contemplate such emptiness is to confront something deeply human, the fear of nothingness. For the void is not just a feature of the universe, but a mirror to mortality. The spaces between galaxies echo the spaces that will one day claim every life, the eventual erasure of all memory into a darkness that swallows names and nations alike. In the Eridanus Supervoid, the cosmos seems to present that truth on a scale too vast for denial. It is not destruction in the familiar sense, but the quiet persistence of absence, carved into the geometry of the universe itself. To study this void is, in some sense, to study death, not with despair, but with awe for the mystery of existence that even absence cannot erase. And yet there is humility in this confrontation. For if the cold spot resists explanation, if the void stretches beyond the reach of equations, then it becomes a reminder that the universe is stranger than human imagination has yet conceived. Scientific progress may close gaps, refine models, and sharpen maps, but mystery is not a flaw to be eliminated. It is a companion woven into the journey itself. The Eridanus Supervoid may remain unexplained for generations or forever. In that endurance, it becomes not a problem to solve, but a symbol of the endless frontier. The acknowledgement that knowledge lives always on the shore of the unknown. As the narration drifts back toward the void itself, one sees not only a hole in space, but the shape of silence. Its immensity humbles the arrogance of certainty. Its darkness reveals the luminous fragility of all that exists around it. Beyond galaxies, beyond stars, beyond the faint afterglow of the Big Bang, the void waits, unhurried and unchanging. It is both a destination and a reminder that even in a universe filled with light, darkness has its rightful place. In the end, the Eridanus Supervoid is not an answer but a presence, a vast and quiet witness to eternity. To gaze into it is to drift once more into the whole, where silence reigns and the measure of all things fades into the infinite hush of the cosmos. The void, when considered not just as an astronomical fact, but as an existential symbol, reshapes the way the universe is perceived. It is tempting to see the cosmos as an endless tapestry of creation, stars igniting in nebulae, galaxies colliding in cosmic dances, black holes devouring matter with violent hunger. But in truth, the scaffolding of the universe is emptiness. More than 80% of cosmic volume is composed of voids, great hollow regions, where galaxies are sparse or entirely absent. The Eridanus Supervoid, with its staggering scale, is only the most extreme expression of a truth that permeates the cosmos. Existence is structured as much by absence as by presence, just as the silence between notes allows music to breathe. It is the void that gives galaxies their shape, their boundaries, their rhythm across time. In this way, nothingness is not simply a lack, it is a participant in creation. Philosophers have long wrestled with this paradox. The Greek concept of horror vacui, the fear of emptiness, suggested that nature abhors a vacuum, always rushing to fill it. Modern science overturned that notion, revealing that the vacuum is not a defect but a foundation, a stage upon which matter briefly plays its luminous part. And yet, the fear lingers. The void forces a confrontation with the limits of perception and control. Humanity can measure it, map it, assign coordinates to its edges, and yet the experience of gazing into such an expanse evokes something older and more primal, the recognition that human life is a flicker within vast and indifferent darkness. The Eridanus Supervoid, then, is not only a scientific puzzle but also a spiritual mirror. In myths of creation, emptiness is often the precondition of birth. From the Norse Ginnungagap, the yawning void between fire and ice, to the Hindu notion of Niyat, the fertile emptiness from which all arises, cultures recognized that what seems absent may hold the potential for everything. The cold spot, etched into the cosmic microwave background, becomes almost mythic in this sense. A scar from a deeper story, perhaps a relic of another universe brushing ours, perhaps the mark of fluctuations seeded before time itself. Science may explain it in terms of probabilities, void dynamics, and cosmic variance, but the imagery remains archetypal. It is a wound in the sky, an opening into a silence older than galaxies, older than light. For scientists, the void provokes humility. Equations may describe dark matter, simulations may replicate the web of galaxies, satellites may map the afterglow of the Big Bang with exquisite precision. Yet, here remains a region that refuses to be entirely reduced to numbers. Some explanations fit part of the picture, none capture it whole. Perhaps the cold spot is partly a void, partly a coincidence of statistical noise, perhaps a hint of something stranger still. Whatever the case, the Eridanus Supervoid stands as a reminder that the universe is not a closed book to be mastered, but an unfolding mystery that reveals only fragments of itself at a time. And so the narration returns to the image of drifting once more across the cosmic web, past the glitter of galaxies, into the profound stillness of the whole. Light thins, voices of stars fade, and the immensity of silence takes hold. The void does not answer questions, nor does it yield to curiosity. It waits, unaltered, untroubled by the gaze turned toward it. For all its emptiness, it holds something irreplaceable, the reminder that wonder itself is not born from certainty, but from mystery. In the Eridanus Supervoid, the universe shows not only what it contains, but also what it withholds. To stare into it is to confront eternity in its purest form, not fire, not light, not matter, but the boundless presence of absence, whispering of truths forever beyond the reach of human hands. The Eridanus Supervoid lingers as more than a scientific curiosity. It is a canvas upon which humanity projects its deepest questions. At first glance, it is only emptiness, a deficit of galaxies, a statistical irregularity in the cosmic web. Yet, when observed with patience, it becomes a profound meditation on the nature of being. What does it mean that such a vast structure exists, not as a luminous cluster or a violent black hole, but as silence itself carved into the body of the universe. The void speaks to the fragility of human categories. Science is trained to measure presence, energy, matter, radiation, but here it is absence that demands explanation. And in this inversion lies a deeper lesson, that sometimes the most important truths are not revealed in what is seen, but in what refuses to appear in human life. Voids have always carried a dual weight of terror and potential. The empty horizon of the sea once terrified sailors, suggesting the world might simply fall away into nothing. The deserts of the earth seemed hostile, barren expanses where no life could thrive. And yet, it was into these very voids that explorers ventured, finding not the end of existence but new countenance, new roots, new beginnings. The Eridanus Supervoid mirrors this ancient tension. Its emptiness may feel final, yet it could be the very frontier that forces cosmology to grow, pushing beyond established models into territories unimagined. If it is only a rare fluctuation, it confirms the strangeness of chance at cosmic scales. If it is more, then it whispers of physics not yet written, laws that operate in the shadows of human comprehension. Cultures across time have embedded this paradox into their stories. In Mesopotamian myth, the primordial waters of Tiamat, an undifferentiated chaos, preceded the ordered heavens and earth. In Greek thought, chaos itself was not destruction, but the fertile gap from which cosmos order was born. The Eridanus Supervoid seems to echo these ancient archetypes, a reminder that emptiness is never merely nothing, but the field in which form takes shape. Science, despite its precision, cannot escape this resonance. To name it a void, to map its contours, is already to acknowledge its presence as something more than a statistical blip. It is an actor in the cosmic play, invisible but indispensable, for the astronomers who dedicate decades to probing its depth. The void is also a testament to human persistence. The cold spot was first glimpsed as a blur of temperature data, later confirmed by satellites that mapped the microwave sky with higher fidelity. Each new survey has sharpened the outlines of Eridanus, but none has fully resolved the enigma. Still, the work continues, because to abandon the question would be to turn away from one of the rarest invitations the cosmos has offered, a place where the ordinary rules bend, where the universe shows its reluctance to be fully understood. There is humility in this pursuit, but also a quiet triumph. To keep asking, despite uncertainty, is itself a victory against the abyss. And so, as the journey closes, the vision drifts once more into the hollow expanse. Stars fade at the edges of perception, galaxies thin into whispers, until only the blackness remains immense, indifferent, and yet strangely beautiful. The Eridanus Supervoid is not an answer, but a question given form, a whole so large it seems to breathe with the universe itself. Perhaps it will one day be explained as the ordinary outcome of chance and cosmic variance. Perhaps it will mark the threshold of new physics, or even evidence of realms beyond this one. But perhaps its truest meaning lies not in solutions, but in the reminder that mystery is eternal. For in the silence of that whole, one hears an echo of the human condition, brief, luminous, and always surrounded by the vastness of what is not yet known. The Eridanus Supervoid stands at the boundary where science becomes philosophy, where observation becomes reflection, where data turns into myth. It is mapped in coordinates and redshift surveys, but the human imagination fills its depth with something more, the haunting awareness that the universe is not merely composed of what is, but also of what is not. The absence of galaxies, the dimming of light, the subtle coldness etched into the microwave afterglow, all remind us that creation is never total. It is partial, fractured, interwoven with silence. The void is not failure, but structure, not accident, but necessity. Without emptiness, there could be no form. Without silence, there could be no sound. In physics, voids are not truly empty. They contain dark matter, stretched thin, cosmic radiation faintly humming, particles flickering, in and out of existence according to quantum law. Yet to human senses they remain unfathomably hollow, great deserts of space-time where nothing familiar takes hold. To picture the Eridanus Supervoid is to imagine a gulf wider than hundreds of millions of light-years, a wound so enormous that the light of galaxies cannot bridge it. If one were to place the Milky Way at its center, it would vanish into insignificance, drowned not in fire but in silence. Whole clusters of galaxies could fall into its breadth without filling even a fraction of its immensity. It is a whole not carved by destruction, but by absence, an architectural gap in the cosmic web itself. For cosmologists, this is both exhilarating and unsettling. The standard model of cosmology, lambda CDM, predicts that voids will exist, as matter naturally clusters under gravity into filaments and walls, leaving empty regions behind. But Eridanus stretches those predictions to their limits, pushing at the edges of probability. Some simulations show that a void this large is possible, but only barely. Its existence may be a confirmation of rare chance, or it may be a pointing beyond the framework that has so far explained the universe with astonishing success. Either way, it resists easy categorization. It lingers at the edge of understanding, defying neat explanation, and so it becomes not just an object of study, but a metaphor for the human condition. Humanity has always lived in the tension between knowledge and mystery. Every age believes it stands near the summit of comprehension, yet each new discovery reveals deeper enigmas hidden beneath the surface. The Eridanus Supervoid is a cosmic mirror of that pattern, proof of how far science has come, and reminder of how far it has yet to go. To map such a whole is to celebrate the triumph of precision and perseverance. To confront its inexplicability is to accept the humility of being small in an infinite unknown. Myths across time have given form to this paradox. In the Rig Veda, creation is described as arising from a state where there was neither non-existence nor existence then, a paradox of nothingness giving birth to everything. In Genesis, the earth begins without form and void, before light enters to divide the chaos. The Japanese Kojiki speaks of a formless void from which the first gods emerged. These stories did not know of supervoids, yet they grasped something timeless. That emptiness is not the opposite of being, but its precondition. The Eridanus Supervoid, vast and silent, is a scientific realization of this ancient intuition. For individuals, the void resonates on a more personal level. Human lives are framed by absence as much as by presence. The fear of death, the silence of unanswerable questions, the spaces between words and moments, these are voids within the human story. To gaze at Eridanus is to externalize that experience, to see mortality written into the sky itself. The fear of emptiness becomes universal, stretched across billions of light years, but so too does the possibility, for emptiness allows motion, growth, creation. Without the hollow space of time, there could be no change. Without the gap between atoms, no matter could form. Without the cosmic voids, galaxies would not cluster, Stars would not ignite, life would not emerge. The hole in Eridanus is not death, but the womb. Science, however, resists sentimentality. It demands evidence, models, predictions, and so astronomers continue to map the void with ever greater precision. Surveys like DES and LSST scan millions of galaxies to trace its contours. Space-based missions like Euclid seek to measure the distribution of dark matter within it through the bending of light by gravity. CMB experiments refine their sensitivity, testing whether the cold spot is truly linked to the void, or whether something even stranger might be at work. With every dataset, the hole becomes both sharper and more mysterious. It is as though the closer one looks, the more it retreats, refusing to be fully claimed. The possibility of deeper explanations lingers at the margins. Some theorists suggest multiverse collisions, the idea that another universe brushed against ours during the earliest moments of inflation, leaving behind a scar visible as the cold spot. Others propose exotic topological defects, cosmic textures left behind from symmetry breaking in the young universe. Still others wonder if dark energy itself might not be constant, but vary across space, with voids marking regions where its density diverges from the cosmic average. None of these theories are proven, many may never be, yet each adds to the haunting resonance of the Eridanus Supervoid. It is not only a hole in the cosmos, but a hole in certainty, a gap where imagination rushes to fill the silence. Philosophically, this raises questions that echo beyond astronomy. Is the universe ultimately comprehensible, or are there boundaries beyond which explanation cannot reach? Is mystery a temporary obstacle, or a permanent feature of existence? The void does not answer. It waits, indifferent to speculation, a silent testament to the scale of the unknown. In its darkness, one sees the fragility of human frameworks, but also the resilience of human wonder. The willingness to confront such vast emptiness, to chart it, to contemplate it, reveals a courage as immense as the void itself. As the narration drifts toward its close, the imagery returns to the whole itself. Imagine a journey into its depths. The glittering filaments of galaxies thin out, dissolving into scattered islands of light. The last star fades, and with it the sense of orientation. Space grows quieter, colder, until even the faint whisper of radiation becomes imperceptible. Here, within the heart of the Eridanus Supervoid, the universe feels like it is holding its breath. No landmarks, no horizons, only the infinite presence of absence. It is both terrifying and strangely beautiful, a reminder that nothingness is not the enemy of existence, but its companion. Perhaps the final lesson of the void is humility. In its silence, humanity hears its own questions reflected back. What is the nature of reality? What lies beyond the reach of observation? What role does emptiness play in the architecture of being? These questions may never receive final answers, and perhaps that is the point. Mystery is not a flaw to be eliminated, but a permanent horizon that keeps curiosity alive. The Eridanus Supervoid is not an error in the cosmic design. It is a reminder that the universe is not built to satisfy certainty, but to sustain wonder. And so the vision lingers. A camera drifting outward from Earth, past clusters, past filaments, until it comes once more to rest upon the vast abyss in Eridanus. The stars recede, light collapses into silence, and the screen fades to black. The final words are not solutions, but reflections. That in this hole, this wound in the fabric of the universe, one glimpses eternity, not as fire or light, but as stillness. The void does not end, it simply is, and within it humanity finds not despair, but a reminder of its own brief flame, flickering in the vastness, daring to ask, daring to wonder,